Hi, I'm Dr. V. Ramakrishna, Assistant Professor, Department of ECE, School of Engineering and Technology, Sri Padmavati Mahila Vishwavidyalaya, Tirupati, Andhra Pradesh. Now, I'm going to present today the spread spectrum communication, which includes the topics of introduction, pseudo-noise, sequences generation and characteristics, direct sequence spread spectrum modulation, which is simply called as DHSS, frequency hopping spread spectrum modulation, which is FHSS, and the comparison of these two DHSS, FHSS, spread spectrum modulation techniques, and after that, applications of the spread spectrum communication. We'll start with the introduction part. Introduction to spread spectrum communication. Whenever the signal which is transmitted by a narrowband digital communication system is more susceptible to jamming and can be easily detected by unauthorized mm, eavesdropper, anybody can hack this message information if it is transmitted directly with a narrowband digital communication system. But when we use the spread spectrum communication technique, and we have transmitted the information which by using this technique, which generally spreads over a wide range of frequency spectrum, using some techniques which are known as direct sequence spread spectrum and frequency hopping spread spectrum, DHSS, FHSS. So with this spreading technique, what we will do is we'll try to protect the information which is transmitted. It is not possible to hack the information which is spread over a wide range of frequency spectrum. Anybody can hack one or two frequencies, but it's not possible to hack entire frequency spectrum. So spread spectrum system becomes bandwidth efficient in a multiple user environment without interfering with another. And CDMA is one of the best technique which is mainly based on the spread spectrum and which is used for cellular mobile communications. Then coming to the definition of spread spectrum. What do you mean by the spread spectrum? Spread spectrum is a transmission technique in which the transmitted signal occupies a larger bandwidth than required, because here we'll use some codes to spread the data in a wide range of frequencies. So that's why it requires larger bandwidth than required. Then coming to the concept of the spread spectrum, the transmitted bandwidth is many times larger than the bandwidth which is required to transmit a baseband signal. Yeah, because of this pseudo noise code. See here, the spreading of narrow bandwidth baseband signal is accomplished through the use of spreading code, which is called as pseudo noise code. Simply PN code. A PN code is independent of the baseband signal. The same code is used to demodulate the received data at the receiving end. So the bitrate of the spreading sequence is much higher than that of the input data. That is why due to this PN codes, the bitrate of the spreading sequence is much higher than that of the input data. Coming to the PN sequences. What is this PN sequence, or simply pseudo noise, pseudo random number sequence? Is a random periodic sequence of binary ones and zeros, 0 0 0 1 1 1 or 1 0 0 1 0, like that. That's completely random periodic sequence of binary ones and zeros. So PN generator, pseudo random noise, or simply pseudo noise generator, will produce a periodic sequence that eventually repeats, but that appears to be random. Now, PN sequences are generated by an algorithm using some initial value called as seed. We'll use the seed value. By using that, we'll generate this PN sequences by using an algorithm. The algorithm produces sequence of numbers which are not statistically random but will pass many reasonable tests of randomness. Unless the seed and the algorithm is known, it's very difficult to predict the PN sequence. That's why this is more secure than the general or traditional system. Because if you know the seed value, for example, if you have used some 1000 or 5000, 10,000 seed value, and the algorithm which is used to generate this PN sequences. If you know both of the seed value and algorithm, then it's very easy to get back the uh, predict the sequences. Otherwise, it is difficult and practical. Next, coming to the properties of PN sequences. Two important properties of PN sequences are randomness and unpredictability. Randomness, unpredictability. How to validate sequence of numbers is random. For that, we are having three criterias and two properties. Randomness, we know every time we generate the tool, for example, say it will generate a random number, binary number, sequence of binary number. Unpredictability, we cannot predict which number will come. So here the three criteria are uniform distribution, independence, and correlation property. These are the three criteria which are used to validate that a sequence of numbers is random. Next, coming to the generation of PN sequences. The PN sequence is a noise-like spreading code which consists of a periodic binary data sequence that is usually generated by means of a feedback register. If you see the block diagram of PN sequence generator, it consists logic circuit, feedback shift register, and clock signals. Clock signal generally apply to all flip-flops which are used to change the state of each flip-flop simultaneously. Here, feedback shift register generally consists flip-flops and a logic circuit. Flip-flop are generally used to store bit data. And here, the feedback shift register is said to be linear when the logic circuit consists of a modulo 2 adders only, simply exclusive or operation which will use and this feedback register, that is modulo 2 operation. Next, coming to the maximum length PN sequence. What do you mean by this maximum length? If a PN sequence is called as maximum length PN sequence, if the period is exactly equal to capital N, that is what the maximum length sequence. If the period is exactly equal to capital N. Here, the number of possible states of the shift register is at the most 2 to the power of m only, where m is the total number of flip-flops and the shift register. The PN sequence eventually becomes periodic with a period of 2 to the power of m. Since the linear feedback shift register does not possess the zero state, the maximum length sequence is 2 to the power of m minus 1. Here, one more important thing is a PN code, pseudo noise code is periodic. M sequences are the most widely known binary PN sequences, and different types of PN sequences are there, like wash codes are one of the important set of orthogonal PN codes. Next, coming to the next topic, that is DHSS, DSSS, direct sequence spread spectrum technique. In this, what we will do is simply high speed PN code sequences used along with the slow speed information data being sent. The data or the information which is at slow speed and the PN code sequences are at high speed. That is what this technique, that is the direct sequence spread spectrum. Information digital signal is multiplied by a pseudo random noise sequence whose bandwidth is much greater than that of the information signal itself. It results into considerable increase in the bandwidth of the transmission. The spectral power density is reduced. And this resulting spreading signal has a noise-like spectrum to all except that intended spread spectrum receiver. Coming to the DSSS with the BPSK modulator, we already know that a BPSK modulator, binary phase shift king modulator, which will have a two values 0 and 1 binary. And here, if you see the block diagram of this, it consists modular to adder, PN code generator, baseband, low pass filter, and carrier signal generator. If you see this diagram, BPSK modulator transmitted. Finally, we will get the transmitted DSSS signal. Here, the figure the diagram which shows the functional block diagram of a DSSS modulator system with BPSK modulation. Here, a PN code sequence is produced by this generator, and the baseband information data is spread directly, multiplying it with a PN sequence. Each bit information, the information data is represented by multiple bits of the spreading code. And single pulse of PN sequence is called as a chip because it has extremely small time duration. Next, this is extension to that. Coming to this DPDSSS DSSS with BPSK demodulator. Again, it consists wideband filter, PN code generator, coherent BAPSK demodulator, and synchronization system. The received D signal is first passed to the wideband filter. Then this system with BPSK demodulator uses a locally generated identical PN code generator and a D spreader. This is the block diagram of direct sequence spread spectrum with BPSK demodulator. Okay. Next, coming to the jamming margin. This is one of the performance metric of this spread spectrum system. The ratio of average interference power and average signal power is termed as the jamming margin. And the expression is also shown. And expressing this terms in decimal form, we can write it as Jm equal to Gp in terms of dBs, right, minus 10 log of EB by a naught minimum. EB by a naught represents the minimum value of EB by a naught. EB is simply energy per bit, and a naught is the noise needed to support the prescribed value of the average probability, whereas this GP processing gain can be defined as the ratio of the gain achieved with the processing the spread spectrum signal and spread signal. That is what the processing gain definition. Okay, next, coming to the advantages of this spread spectrum, especially DSSS, low probability of interception. The transmitted energy remains the same, but the wideband DSSS signal looks like noisy to any receiver that does not know the signal's code sequence. So there is extremely low probability of intercepting the signal. Second advantage of this spread spectrum, this direct sequence spread spectrum is increased tolerance to interference. So this DSSS modulators process a narrowband information signal to spread it over a much wider bandwidth. Spreading the information signal desensitizes the original narrowband signal to some potential interference to the channel. Third advantage is increased tolerance to multipath. Here, increased tolerance to interference also means increased tolerance to multipath interference. In fact, the multipath energy may be used to the advantage to improve the system performance. And the next advantage is increased ranging capability. Timing error is directly proportional to the range error and inversely proportional to the signal bandwidth. This property enables direct sequence specific and signal to measure distance or equipment location through a method known as triangulation. That means first we'll send a message and we will wait until it receives back. So we'll calculate the total duration of the time from the transmission until reception. That is what the triangulation process, which we'll use here to increase the range. It's similar to like we'll also use the same technique in radar systems. Similarly, here the spectrum communication system is also used this triangulation technique to increase the ranging capability. This is these are some advantages of direct sequence spectrum communication. Coming to the FHSS, frequency hopping spread spectrum modulation. That is the second technique. First, we have started with the introduction to spread spectrum communication, and after that, how to generate the pseudo noise sequences, which plays an important role in spread spectrum communication. Then the types, direct sequence spread spectrum modulation technique, then the frequency hopping spread spectrum. We have discussed in detail about the direct sequence spread spectrum modulation.